What's up, math fans? Here we go, lesson 705, finding the apothem. So our aim here is to learn how to find the length of the apothem if it is not given. Remember, we need the length of the apothem to find the area because the area of any regular polygon is 1/2 times the length of the side times the length of the apothem times the number of sides. So we need that apothem length, but we're not always given to us. So let's do a little bit of review here because these ideas are going to be relevant for today. So this is trig and special right triangles, and this is from lessons 404, 405, 406, 407, and 408. Check your notes for these. So the sine of some angle, we generally refer to this as theta. Remember, that's just a Greek letter. You can call it x if you want, that's fine. So the sine of theta is the opposite leg over the hypotenuse, cosine of theta, adjacent leg over the hypotenuse, and then the tangent ratio here, the tangent of theta is the opposite leg over the adjacent leg. And we remember this as SOHCAHTOA. That's often how we refer to it. So again, sine is opposite over hypotenuse, cosine ratio is adjacent over hypotenuse, tangent ratio is opposite over adjacent. And then again, this is also review, special right triangles. There are some special relationships that we can find in right triangles sometimes. In this case, this is a 45, 45, 90 triangle. And if that's the case, both legs are gonna have the same length. So we'll just refer to them as x. Doesn't matter what x is, but we just know that they're the same. If you wanna find the length of the hypotenuse, just multiply it by the square root of 2. We get to use this as a template. So for example, if x is 10, say each of these sides are 10, and we wanted to find the hypotenuse, just do 10 times the square root of 2, and you'll have the length of your hypotenuse. You can do this for any 45, 45, 90 degree triangle. Same sort of template or pattern is true for a 30, 60, 90 triangle. So the bottom leg we refer to as x. It could be any number. It can be 5, 10, it can be 1,000,000, it could be whatever, any positive number. If you want to find the length of the hypotenuse, just double that number, and that will always be true. So if your this leg here, your short leg, has a length of 7.5, let's get weird, 7.5. Then the hypotenuse here, you would just double it, 2 times 7.5, which lands us at 15. In the same way, if you want to find the length of the longer leg, it'd be 7.5 times the square root of 3, and you could throw that in a calculator, get a decimal approximation if you'd like. Okay, this stuff is going to be relevant. Let's get into this. So this first one, what if the apothem's not given? We have the tools needed to find it. And what are those tools? It's what we just talked about. All right, so find the apothem of this equilateral triangle. We know it's equilateral because these are all regular polygons. So if that's the case, each of these angle measures is 60 degrees because we know that they add up to 60. They add up to 180. Boy, they add up to 180 and they all must be the same. So it's an equilateral triangle, 60, 60, 60. And I split this one up down here into two 30-degree angles because the radius bisects the angle. So part A, what does the 18 represent? I wrote radius. I really should be more specific. This should be the length of the radius. That's what's given to us. So we'll draw on the apothem and explore the triangle created. So I drew in this red line here. It's perpendicular to the base, and that created this triangle here. So A represents the apothem. 18 is that radius, which happens to be the hypotenuse of this little triangle we just created. Down here, we have the 30-degree angle. That's what I tried to represent here. And up here is a 60-degree angle. And I knew that because we had a 90 and a 30. And I knew that these all had to add up to 180. So 90 plus 30, that's 120. And then the remainder must be 60 because these have to add up to 180. Now, we found ourselves in a situation where we have a 30, 60, 90 triangle. So we're going to use that fact. In this case, the short leg is our x value, or our apothem. So we don't actually have that. How funny. So what we ended up doing here is we took the length of the hypotenuse, which you know has a value of 2x, and we wanted to find what our x value is. So for us, again, the apothem is the x value, so I'll even write that. X equals this, whereas 2x equals 18. So hopefully you can see if you just want to solve for x, divide both sides by 2. 18 divided by 2 is 9. And that x value has the same value as what ends up being our apothem. So our apothem is 9 units in length. Let's do another one. Number 2, find the apothem. Here we have a regular quadrilateral, also known as a square. Each of these angles here is 90 degrees. If you add them all together, it equals 360 degrees. And then this radius here divides this one into two 45-degree angles. The radius length given to us, again, let's clarify this piece here. This is the length of the radius, is 12 root 2. I know that looks a little clunky. You can write that as a decimal approximation if you so choose, but it actually helps us in this case to leave it like this, and I'll show you why. So we'll draw on the apothem and explore the triangle created. drew in the apothem, this red line here, it matches this red line here. And then we have that 12 root 2 is our radius, and then this side here, which we don't know. This is a 45, 45, 90 triangle. Again, right angle by design, 45-degree angle right here, because this was bisected by the radius that was given. The remainder must be 45. So we're going to use this special right triangle template. Notice how our hypotenuse has a length of 12 root 2. Notice how this hypotenuse has a length of x root 2. So whatever number out front of the root 2 is our x value. Notice here in the template, the x value is the length of the legs. That's pretty sweet. That means that our a value just has a length of 12. I showed a little bit of the algebra here. 12 root 2 divided by root 2 to get to 12. So the apothem is 12 units in length. Again, if you have some number, say in this case it is 12 root 2, and you wanted to find out what the x value is, you could just divide this by the square root of 2, yielding whatever x is, which is 12. Okay, this last one, here we go. We're actually going to find the area here, so we're going to take this one to the next level. First things first, how many sides does polygon have? Well, I'm counting 1, 2, 3, 4, 5. So we have 5 sides. What is the length of each side? Well, that's interesting because we're given that we have a perimeter of 10 yards. Well, that means all 5 sides, when you add up their length, the result is 10. But it's a regular polygon, so they're all the same. So we just divided 10 by 5. 10 divided by 5 is 2. So each side has a length of 2 units. Okay, part C, what's the measure of each angle? We'll use our formula, s minus 2 times 180. So s minus 2, and 5 minus 2 is 3, 180 is 180. 3 times 180 is 540. Now this 540 is not the measure of each angle, that's the sum of all of the angles. So then we take our 540 and divide it by 5 because we have 5 angles. 540 divided by 5, my calculator told me it was 108 degrees. So we're going to use this fact. That's where all these 108s came from. And then this one chopped in half, so the 108 is 54 and 54. Okay, we drew in the apothem and a radius, and I removed that triangle here from the noise a little bit, so we're just going to focus on this triangle here. We know that the red line here is our apothem. I labeled it A. We don't know the length of this hypotenuse, or the radius of the regular pentagon here. We do, however, we know that this has a length of 1, this side here, because we know the whole entire side is 2. If we chop it in half, it's 1. So we have this triangle with, it's a right triangle, has a 54-degree angle, has an apothem, which we're calling A right now. We need to find that, and then a shorter leg of length 1. So we're going to use some SOHCAHTOA. I'm noticing we have a 54-degree angle, so we're going to view the triangle from the perspective of the 54-degree angle. We have a piece that we know, this is the adjacent side length is 1, and then the opposite side length is our unknown, which we're calling A. So looking up here, the opposite side and the adjacent leg, the ratio with those two values uses tangent. So we're going to set this up as tangent of 54 degrees, tangent of 54 degrees equals the length of the opposite leg divided by the length of the adjacent leg. Opposite leg is our unknown, our A, our adjacent leg is 1. Okay, well that's kind of cool. Dividing by 1 is sweet. A divided by 1 is A. So now the tangent of 54 equals A. So our apothem here is just whatever the result of tangent of 54 degrees is. So typing that into your calculator, tangent of 54, and you'll find that the apothem is 1.38. Great, this is the new stuff for today. This next piece, this is old news, but we are going to find the area of this regular pentagon. So the area is 1/2 times the length of the side times the apothem times the number of sides. 2 from right here, 1.38 from right here, 5 from right here. Plugging this again into our calculator, and we've learned that it's 6.9 square yards. So what's our area? 6.9 square yards. Okay, hopefully this helps. Let me know if you have any questions. You got this.